Remember that there are three primary error types. There are syntax errors, where Python doesn't understand the instructions, runtime errors, where Python understood the instructions but something went wrong, and there are semantic errors, where Python ran successfully but just didn't compute what we wanted it to. Testing helps us detect that third kind of error, semantic errors, to test and ensure that our code actually produces what we want it to produce. When testing, we'll use the unit test framework. So far in this course, we've been writing the tests for you, but now it's going to be up to you to write your own tests. And essentially what you're going to do is you're going to write out what your program should do and test that it's actually doing that. And while that sounds simple, coming up with good tests really is almost an art. When you write tests, you should write them to maximize coverage. For example, if you have an if, else block, then you should have tests that try to hit all of these conditions. We also want to test edge cases to test things that are valid but maybe unexpected. So for example, if your code works with a list, think about what would happen if you passed in an empty list. If you work with a string, what happens if you pass in an empty string? If you work with an integer, what happens if you work with an odd value like 0 or a negative integer? So let's say that we have this mul function, which is supposed to return its two inputs, x and y, multiplied together, and we want to test that it works correctly. In this class, we use the unit test framework, which we import using import unit test. And then to use the unit test framework, we need to create a class that inherits from the unit test.testCase superclass. So I'm going to create a class named myTest and specify that it inherits from unit test.testCase. And unit test.testCase provides several methods like assert equal that help us test if our code works correctly. Then we can enter in any method name as we want, as long as it starts with test and underscore. And inside of these tests, then we'll call things like assert equal. So here, assert equal again is a method that's inherited from unit test.testCase, and the first argument to assert equal is what we're actually getting. So here I'm saying I want the value of mul 2 and 2 to be 4. So this is the expected value, and this is the actual value. We can also pass in an optional third argument, which is just a summary of what our test is testing. So here I'm just saying that I'm testing that 2 times 2 is equal to 4. And then finally we need to be sure to call unit test.main to actually run our tests. Unit tests provide a few assertion types that we can use. The only one you really need to remember is assert equal, which checks to be sure that expression A is equal to expression B, and if they are equal, then it passes the test. If they're not equal, then it fails the test. Assert not equal does the opposite. It passes if A and B are not equal, and fails if A and B are equal. Assert true passes if X is true, and fails if X is false, and assert false passes if X is false, and fails if X is true. The only one of these that you really need to know is assert equal, because all of the other assertion types can be checked using assert equal. So in our test, we're going to assert equal that mul 2 and 2 is equal to 4. And when we run our code, we see that it actually passes our tests, which we can see with this little OK in the output. But despite passing this test, our code for mul actually has a bug in it that this test didn't detect. In it, we're multiplying y by y instead of multiplying x by y. This test just so happened to use inputs where x and y were both 2, so it didn't detect the bug. And that just goes to show that passing a test doesn't prove that the code is correct. So now if we add an additional test where x and y are different, then our error gets detected, and we can see that our test failed. In particular, we see that our output produced 9, whereas it should have produced 6. So testing helps us detect semantic errors to test and ensure that our code works. We use the unit test framework to write and run tests, and essentially what we're doing is we're writing what our program should do and testing that it actually does that.